Good afternoon, everybody. Welcome back to episode number 13 in our Oxygen Not Included Redux series. Done a little bit of setup here on Gargani to try to get some things rolling. First, I opened up this flush geyser, and I'm setting up a little bit of a power plant system. So, I'll walk you through what I'm planning here. The polluted water is going to feed arbor trees, which are going to produce lumber, which will be turned into ethanol, which will run these petroleum generators, which will power everything here, and the excess polluted water will go to our bod bucket farm, which will provide us with food for this colony. It's just a temporary measure until we get sustainable food up. This will hold us over. That's the plan. So the water coming out of here is going to have to be between, look at our bog bucket, 10 and 30 degrees. If we look at our arbitrary, between 15 to 40. So we're going to shoot for 20-degree range. Means once this is up and running, have a tepidizer in here, going to be set, heat up until the water is 20 degrees, and then it'll shut off, and when that happens, the pump will turn on, pumping water out. As colder water comes in, cool down this water, and it will kick it back on. That's the plan. I need to set up, probably want to set up a reservoir for our ethanol. And the other thing I'm working on is digging up here to get into here to just start using some of the ethanol we already have on the map. I want to use it up. Our goal is to make it sustainable, continue to provide us with ethanol on demand, provide us power. I also need to put in spaces for the polluted water from the petroleum generators to drain out, because we're going to be producing 750 grams per second when it runs. I can't remember which tile that on. So once I figure that out, I will put in some tiles. But the idea is the top polluted water that comes out of here will also help to heat up this water and keep us rolling. I still need to get this slush geyser analyzed. Still need to get all the little bits and bobs built, but we're mostly there. Copy this across these, across this and here. But the reason I wanted to get this running slightly sustainable for now is because I need to go back to the main colony to do some work today. We've been having a lot of power issues. Not really an issue. It's just that we've reached the point where we are regularly kicking our coal generators back on. And we don't really want that to happen. That's supposed to be backup power. If we're hitting into that, that means that we are not keeping up with our load for power. And I don't think it's a supply issue. We have plenty of fuel to supply. Sometimes it runs a little low, but mostly it's a load issue. So we want to get petroleum going, because these produce 800 watts. These produce 800 watts. These produce 600 watts. Each of these can produce 2,000 watts power. So the petroleum generator is going to make a ton of power for us once we get it running. But that means putting in a petroleum boiler down here so that we can get the petroleum that we need to run it. I have been working to get the oil out of here separated. So that's gonna do. And the other thing is that we're producing oil here pretty quickly. So I put in some automation so that when the oil gets up to this level and it goes above 500 kilograms, it'll shut down this oil well, so it'll stop pumping out. This one will keep going until it gets up to this level, and then it'll stop. But that's happening pretty quickly, making a lot of oil. So the first thing I'm going to work on today is getting all of this crude oil out of here and into one of our reservoirs over the side. I was building it up to try to push it over, but this is rising faster than that. So what I'm going to do, put in a pump, and we'll just pump it up this way. We can just go above, put a drain out. All we need is power for that. Have some excess power here, I think. Potential load's 1440. That's on a power line down here, and we'll start pumping that oil over here. Once we get that done, we're going to want to get all the gases out of here so that we have an environment that we work on building our petroleum generator or petroleum boiler. We're going to put the boiler kind of right in the middle of this area because we're going to be using the geothermal power. So our spike we want to tap in like right here, start pulling heat out, making petroleum. Ready to bring in our 5th colonist for our 2nd asteroid, Cleveland. So what we've done over here is set up a little bit of a power grid. I have a couple of lines coming out of it. We have 3 ethanol distillers making ethanol from lumber. That is getting pumped in as a secondary input here. Primarily, we are emptying out these ethanol reservoirs up here. I'm running new lines to this one up here so we can collect all the ethanol around that. Then that'll give us time to get some lumber stored up, which we will continue to produce ethanol in the future. Should give us quite a bit of time to run everything. Put this there to store lumber in. Easy indication of how much we have. We have 5 duplicates in here now, and I have the bog buckets growing. So the bog buckets, see the bog. There we go. Bog bucket grows. Life cycle is 6 cycles, 6.6. So let's say 7 cycles. Every 7 cycles, it gives us 1.8 calories. But then that is turned into bog jelly is turned into swampy delights, which gives us 2.2 calories. So every 7 cycles, each one of these plants gives us 2.24 thousand calories. So we take 2.24 times 25 plants, divide that by 7, get about 8,000 calories per cycle coming out of this farm if we can keep it with polluted water. So as long as this polluted, or this cool slush geyser and the power provides enough polluted water to keep these plants running, we have a surplus of food on Gargani farm. We also are using the polluted water to run the arbor trees. We got to see if we're going to end up surplus of lumber once we get all these planted, but that's going to take some time. I have a couple of wild arbor trees growing here. Pips are going to keep planting them, so that'll help us too. So I'm going to leave that farm going. May actually be a good idea. Put in a door here, and then we'll put in critter drop off so that we can start putting our pips in here. We'll turn this into a pip state and keep the arbor trees being re. Probably a pretty good idea. Out arbor. Actually, probably make it into nature reserve. Do it eventually. We need to do that. So we are finishing building out this. I made it a little bigger so we can fit 3 power plants, and then the 2 lines coming out so we had enough that we can use a little power in the base. We're getting the 3rd ethanol distiller running. I don't know if we'll actually even need that, but put it in. I have 2 reservoirs that hold all the ethanol that we can get into it, so we have a bit of a buffer, and that, like I said, is helping us to empty tanks out, or these reservoirs out. So this will run for a while. We'll have food for a while. It'll keep its temperature for the base. So everything should be good here on Gargani for the foreseeable future, which means we are now free to go back to Ideolis, the asteroid, where we are emptying the crude oil from here into our tank on this side. We can see that this one is shut off because the hydro sensor says there's too much oil in here. Exactly what we want to see. Actually, mesh tiles there so that the oil will flow up and over it. That way we can get oil going up here. Once it gets into the point where it fills this up, this will also shut off. But we have a lot of oil in here that we will start processing into petroleum. And we also have a lot of oil on this side. This I already started building off because we're going to let this one run into the tank on this side. So what I'm going to do, deconstruct those two, go down 2 more layers, like this, and we'll open up this so that we can let the excess flow down. So once I get rid of all of these tiles, let's wait until this is done before we break those out. That way this oil level can go down. We're just trying to get all this oil out of here as fast as possible because I need to get rid of the oil and the carbon dioxide in here so that I can start building our petroleum boiler. Working on this on 2 fronts. One, I am lowering down this reservoir a little bit to make some space for oil to go into. And over on this side, this carbon dioxide is taking forever to be vacuumed out. So I added in 6 gas pumps. They're quickly pumping away all the carbon dioxide over here. Start drawing it through. We'll get it all out. We're just venting it in up here. It'll come over here, work its way down, and get pumped into this due course. No rush. So the goal is to get this to be a vacuum so that as I build the petroleum boiler, I don't have to worry about gases being inside of it causing problems. I've been looking back and forth at this and trying to decide where exactly I want to put this boiler. And I think that this is the perfect spot because this abyssalite is already heated up. And that's why I have an insulated tile here, creating a buffer for us. And it's always annoyed me. And now I can get rid of it. I can put my heat spike right through it. We can get down here, use up this little bit, and we'll go down and spread our way out in both directions. And start pulling magma out. It also means, in the future, my thought was I would tap into this volcano and make a tunnel that just drops the magma down right into here, which means that if I leave space on this side of the boiler and make the boiler go this direction, then I can drop the magma in right over here and add it into our magma pool as we need more in the future, which won't be for quite a long time, but the possibility is there. So I'm going to finish getting all this oil into our 2 reservoirs on either side and getting all this carbon dioxide out, and then we're going to start assembling our petroleum boiler right in this footprint right here. So I got all the oil out of here, but I wasn't thinking when I put in these gas pumps. There's a bottleneck right here. Now, this one is pulling in gas, but none of the other ones are getting anything. So it might as well just be one. I'm removing all the other ones. I'm going to let this keep pumping at this end, but then I also installed 6 more pumps down this end. They are pulling out gas as fast as they can. So we're slowly getting a vacuum pool. It's going to take a while because there's a lot of volume to do. At the same time, I am removing all these tiles I used to push the oil up to a higher level. And I'm also removing, pumps, things like that I had for the oil. Get everything just back to where we need it to be. Next thing I'm going to do after that is I'm going to run a transit tube down to in here so that my duplicates come straight down in, instead of having to travel one side and then come all the way across. Help with getting their commute. You can see our water is actually getting processed pretty good. We can see by how much water is getting pulled back to the side, how much we've gone through the... It's going down quite a bit. I'm also mopping up the excess that was on the level above. That can keep working while we're working on everything else. Ran into a little bit of a snag. Our pump hit polluted water. It's almost done with clean water. And so if I come up here to our water processing, I had it set up so that this was just cut off so the polluted water didn't go into the sieve to clean it, which meant that this filter completely backed up with polluted water because I had nowhere to go. So instead I cut it off at the input, and I'm letting polluted water come out through the filter, get processed into water. Now the water and the polluted water are moving again. It means we're pulling water up from the bottom of the map again. And we'll be good until we hit salt water. Then we'll deal with it. Probably set that up now. And just do the same thing. So make it so that this is cut off. And we can reconnect this. This will only process water or salt water until this shuts off. Is set up to stop processing liquid. Have it allowing more in. This will keep pumping and running until out. Should be okay. We'll process through a lot of salt water. I guess what I could do is put in another one of these, and then just put in automation to make it so this will shut off. This gets below a certain threshold. This doesn't let salt water in if it's not below 500. Set this one to be below 100. So if it goes below that, it'll still have room for the salt water to come in, but it won't keep processing. That's what we'll do. But that means we'll be able to process salt water through, we'll be able to process polluted water through, and water through. The only other liquid in the bottom of the map is crude oil, and when the crude oil gets sucked up, it's automatically filtered back into our crude oil reservoir. A problem that I needed to address sooner rather than later. Transit tube access I built down at this level. When I set up the automation to shut off the oil production, it's at this level. It means this oil is going to continue to fill up until it's up here. So if this transit tube is down there, it'll get flooded. Any duplicate in not be able to get back out. So I moved that one on the left up. Same on this side. I need to this. Build this one up on the other side here. The other thing I'm going to work on is that I want to have transit tubes that run towards this area where I'm going to be building the petroleum boiler. So I have it come down like this. Do a mess. We'll have to put some scaffolding up over there to build all that, but that's where the new line's going to run, and that way we will have our duplicates be able to come down right next to it, which will be helpful. The carbon dioxide is still at like the 300 milligram level, but it started at the 3000 level, so it's going down pretty steadily. Before long, we will have a vacuum pulled over here. Means we can start our construction. I'm going to start laying it out, but I don't want to actually start building the layers until after we have the vacuum set up, because it'll be a lot easier to build after the vacuum is there rather than trying to do it while they're or trying to pull a vacuum out of it afterward. Okay, so there we go. There's that. We're going to need to get power down to here. Let me see. Is this power? One is running 80, but 1440 of that is the gas pump. So I could definitely use this long to power our transit tube. Here we go. So once they build all that, we will have transit tube access down here. Finish this section real quick. They removed everything. All we have to do is put that in. Get rid of our ladders here. Build the transit tube itself. And then once everything is built, we'll have access for them to come wherever they need to and get out of the area without any serious. I'll connect this transit tube once I'm done with this gas pump. Very soon. Gotten most of our petroleum boiler built up. I'm just waiting for the vacuum to finish before I start sealing this up. The premise here is pretty simple. The oil comes in from here, goes up, and then it comes down here. It goes through all of the petroleum and heats up in a counter exchange all the way up here where it drops in. Automation here tells it to close the door if the temperature there is below 403. Right now I have it set to above because I have that switch. So it's fine. Temperature goes below 403. It should send a green signal. So if I think that's that. It's I always think of these backwards. I want the door to be closed till it hits 403. Yes, that's correct. That means if I had this closed, or this switch turned off, it would close the door because these are telling it to go, and then when it goes above 403 to open or turning off. That is exactly right. And then this diamond tile is a spike that goes down in to soak up the heat. So once we connect that, it'll pull heat up the oil, and then when it gets down to here, this pump will pump it out and put it into this tank that I'm building here. That then pumps all the way over here and up to the top of the map and over to our petroleum power at the top. We have a couple more pieces of air that need fixed. I have a port to do it. This one I need to actually run across for that way they can finish building that, so that once we get this running, we can actually start using the petroleum right away. The basic design of this I got from Luma Plays, because I didn't feel like figuring out all the math for how long I needed the counter exchange to be. And their designs are actually really cool. Do a lot of quick tutorials on YouTube. Check them out. But I'm going to get this finished up. I got to get all the gases pulled out. Getting really close. We're down into the micrograms now. So once it's all pulled out, then we can seal this up. We can start running some fluid through and find out what we screwed up. While I've been waiting on the carbon dioxide to be pumped out of petroleum boiler build, working on tips. They plant seeds. I know that as they eat from the arbor trees, they can get seeds. So far I've only gotten 2. And I haven't gotten any extras for here either. I'm not sure. Not sure how the seeds work for them, but I do have plenty of lumber coming in. I have this fully stocked, and I'm still burning through the excess I have on the map, so It's fine. I did collect all the fluid down here together, set up a pump so that we keep this room full when dormant. I think it's just about to get back into activity. So I set it up in such a way so that if this does pump out more than we can use, it will spill over the edge, and this fills up until it's at 250 kilograms. Then it stops pumping more in. So we have a little bit of space to hold the polluted water that's coming out. So it's working fine for now. Not permanent. For the time being. Go back to our main colony and check on there. So I have finished most of the build, and I'm just waiting for the very last micrograms of carbon dioxide to get out. We have up here, we're almost completely gone. Farthest corner down here, we're at 136 micrograms everywhere. So it's almost there. As soon as it's completely gone, then we can fire this thing up. I set up this pump, sends oil up, prioritizes the oil that goes up here for our plastic production. And use some plastic. That's fine. The after that's filled, the oil gets shifted over to here, and it drops out on the same level as this, and the shutoff is set the same, so when this shuts off, so does this, and we don't get any more or oil at this level or below. So everything here will work. So pumping out the last little bit of gas on the side of the well and put a barrier in. And this will keep going until it gets up to this level, which means that we won't have any more oil other than here, which means our slicksters are fine no matter what. So that's how that's all set up. So we'll be able to pull the oil from different places, prioritize. We're down to 45 micrograms. We're just waiting for it to go. Problem is that as you get closer and closer to being completely done pumping out gas, it gets harder and harder for the pumps to do, because there's just not gas there for it to pull. Eventually, it'll hit a point where it all collapses. Get turned to vacuum. It's going to take it a few more minutes to do it because of how large the space is. But we're getting there. As soon as we get to that point, we'll be able to turn the pump on, to pump oil in, and connect our heat spike up. And we'll be able to actually see this thing in action and look for any flaws that I've done. Which I'm sure there probably are some. So, I'll come back once we get this last little bit of gas out. Pumping all the gas out of this chamber took very, very long. See, this side is still low. But I've gotten the whole system up and running. I've done a lot of testing with it, making sure I have everything work. I had to adjust some, but I'm pretty sure everything's working pretty well now. We're starting to dig down into the magma, pull out the heat from down in. We have pretty good solid temperature the whole way through. So just to explain how this works, again, this is not my design. Got it from Uma Plays, but the way that this is set up, there is an airflow tile made of steel that wraps the heat spike. The idea for that is that none of the liquid can get next to this window tile, so the heat can't transfer. So this, we don't have extra heat. Petroleum make gas. Any liquid were to get down here to the spike, we're good. Continue to break down into the magma chamber. Let the magma get to the heat. Carry all the way up. Here, temp shift plate helps the heat mortar here so that this tile stays even the whole way across. Door, when it gets closed, transfers the heat above it to this tile, puts it into the oil, and turns it into petroleum. So there's two sensors here. As long as the temperature is above 403, we don't have any more heat come in, because that's where we want to keep it at. If it ever drops below that, this will shift some heat in. It will very quickly boil off whatever crude oil is in there. Slowly, you go back. So we're only using heat absolutely have to, and so it's not using the map too fast, and it controls the oil to petroleum conversion here. So that's working great. Flows back down this way so that there's a counterflow heat exchange. So the oil coming in from the pipe starts at 73 degrees, goes through here, and it heats up through this petroleum as it goes. By the time it gets up here, it's practically at petroleum. It just needs a few more degrees to get there. Once it lands in this hot petroleum, it turns to petroleum. And if it cools down to the point where it can't do that anymore, it heats back. Then on the other side of that, the petroleum is coming out of here at 400 degrees. As it works its way down, by the time it gets down to here, the petroleum is down to 20 degrees. Which does a couple of things. One, it keeps all this from overheating. Two, it also means that the petroleum we're pumping out is cooler. And then that petroleum is getting pumped out to be used in. Look at our power system up here. Pumping petroleum in, getting polluted water, carbon dioxide out. Enough to keep our entire system set power right now. So power, again, this is set up for automation so that it goes on when the batteries get below 50. If this can't power them back up to the point where the batteries come back on by the time they get to 30, natural gas fires on. Still not enough. By the time it gets to 20, hydrogen will kick in. And if it dips all the way down to 10, coal will kick in. Most of the time, this will keep the power up high enough that we will not have any issues staying on. So it has to fall. 30 would be 6. Oh, these are enabled. There's no natural gas. Pipe is blocked. Why do I have 37? Not able to keep up. Okay, we'll have to look at that. We're having some problems with this pump is supposed to pump out carbon dioxide, and it's pumping it out, but not as fast as we generate. Okay, well, we'll have to work on that. Probably just put in a second pump, see if that's enough. Let me think about the math here. These are generating 500 grams per second. 5 of them are running consistently, so it's 2.5K per second, plus whatever we're getting. We'll probably have to run multiple lines for our carbon dioxide. That's actually a pretty good thing, because that means we're probably getting a lot of carbon dioxide down here, which is feeding our slicksters. Got this. Got this. Now that you've gotten. Anyway. We'll work on that and fixing the carbon dioxide up in here. And I think we're going to call it a day for today. We've gotten quite a bit done. We have Gargani up and running fully, producing its own food, having its own power. And we've got petroleum power here on the main colony. That's pretty excellent. So hope you enjoyed watching it, and we will see you in the next one. Bye-bye.